Hi, everybody. Good afternoon. And my name is Jack. I'm from Intel NAND Solution Memory Group. I have today quick presentation about the Intel, what we do on the Ceph, on the NVMe solution, and as well as the Intel new technology on Optane based on 3D XPoint. My colleague over there is Zhang. Zhang is he lead all the Intel software group to develop the Ceph code. We are the second contributor for the Ceph development. So basically, I'll give you a quick introduction of the Ceph. Ceph got block store, file store, and object store. And according to the survey, there's 60% block store as a backend of Cinder, OpenStack. So Ceph developed through the last 10 to 12 years is getting to be dominate the block store over the various horizontals. This slide is not good, but basically we did 3 recommendations for the Ceph configuration. The first one we think is like more appropriate for the object store. We use NVMe or SATA SSD as journal, and plus HDD as OSD. So you have fast performance on write, and as well as the low cost capacity. The second one we developed we call it good, better, best. The second we got a better solution, which is All Flash, but you use NVMe SSD as journal plus SATA SSD, because SATA SSD is still cheaper as today for the cost. And then you're using NVMe as journal, so you get faster write. You use SATA SSD as OSD, you get a better IOPS performance. I mean, small file size or block size, random read-write performance. As well as a relatively lower cost because SATA is a lot cheaper than NVMe and PCIe as today. I'll talk a little bit later for tomorrow or next year. So the last one is all NVMe solutions, which is give you fastest performance as of today for the Ceph. Basically, you use the 4 NVMe's as per node. Then you get lowest latency. Is the last 2 for better and best. You can all achieve, like for 5 nodes, you can all achieve like 1 million IOPS, about 1 million IOPS for 4K random read, and get about 120K IOPS for 4K random write. But today we are talking not this 3. We got new advance, because Ceph going to release BlueStore, downstream BlueStore by next spring. So we go ahead, we'll skip this page. We go ahead to do a lot of works on the BlueStore and also tuning. This is I credit to the China PRC Shanghai team, Intel team. They did a lot of works under Jian's team. This is one configuration we did in the lab, 5 node. Each node, we got P3700 as journal. This time we use as RockDB WAL. Basically, you store the MAC data. And then we use new release Intel P3520, which is 3D NAND SSD. 3D NAND, I'll talk a little bit later about the 3D NAND technology. This give you this 3D NAND SSD is as lower, about compatible with the SATA 2D NAND price as a price level. I mean price perspective. So basically, this we want to replace our better configurations with all NVMe solution, because with NVMe and PCIe interface, you got much, because you remove the middle layer of the HBA or read card controller, you connect to CPU directly through PCIe. So basically, you remove 1 layer latency, and your performance is going to scale out faster, better than the SATA or SAS drive. So in this configuration, we got, it's not good, but for 4K random read, we got 1.25 million IOPS for random read. And if you look at the random write performance, it's doubled with the previous file store. It's 270 or 280 K IOPS. So if you look at the current fast file store, 4K random write is about 120-25. Okay, this is because the algorithm, the BlueStore, you remove the file system, you talk to write to the drive directly. This is quick chart with the performance. As you can see, a lot of the for write and for read, sequential read, and we already have throttled at a NIT card. So we have do NIT card, do 10 gig, this configuration. So next step, we're going to move to upgrade to the NIT card to 40 gig, and we believe this is going to be scaled out a little bit more. Our team also do not, because the Ceph itself coming from 10, 12 years ago, is a lot of complicated algorithm. It's not favorable to SSDs. We have a China team. They do a lot of tuning. They have C tune. They can do deploy Ceph. They can do benchmark. They can tuning a lot of parameters. So those, it's not just like you plug in the SSDs, you get better performance. You have to do a bunch of tuning works, including the code change. This through 4-5 tuning PKMs. We publish those on the with Intel web page. You can get 1.5 performance increase. So next we can talk about Intel Optane drive and Intel 3D NAND SSDs and how we can help on the Ceph and OpenStack. So basically, Intel moving two directions for the non-volatile memory solutions. So one way we're moving, look at this chart. In middle is a CPU, and CPU DRAM. People struggling, a lot of they're struggling on where to put the data, right? The data coming more and more, and we like one person can get 1.5 or 2 gigabyte data per day, and up to the Genome, hospital, your data getting more and more. Where you put the data, right? The closer CPU got expensive, DRAM, SSD. You're moving out of the outskirts, you're cheaper, but your performance is lower. So on this chip, closer CPU, everything is expensive. Far away CPU is cheaper, but performance is lower. So right now between the SSD and DRAM, there's a gap. So Intel feel that gap with our Optane, we got Optane technology. It's based on new medium technology. It's totally different from current NAND technology. So we built that and fill the gap. So we're approaching to DRAM, trying to replace DRAM-like applications with the Optane technology. The other way we have 3D NAND technology. It's built on the floating point technology. It's different from many of our competitors. This gives you high dense. You can do by this year, end of this year, we're going to have 4 terabyte MLC or TLC per drive, like 2.5. And by middle of next year, we're going to do 8 or 16 terabyte per 2.5, like regular SATA drive. So those gives you our opportunity. Give the industry opportunity to dramatically reduce the price cost and open the door to let the SSD performance, low power and low fail rate, this kind of technology to remove the hard drive, to replacing the current hard drive. First, SAS hard drive, then moving forward 2-3 years, even your code editor can be on the SSDs because the cost. This shows where the Optane drive between the current memory architect. DRAM, Optane drive is like 100 or 1,000 times high density than the DRAM, lower cost. It's still slower, lower than, performance is slower than DRAM, but you can get high density. But this Optane is faster, like 100 times faster than current SATA or PCIe NAND-based SSD. This is quick. Our prototype is coming, and this is a quick performance test on the RockDB. This is RockDB test 5. Basically, you can, without further tuning, the Optane drive already have 10 times faster. The latency is 10 times better than the current fast PCIe SSDs, and the throughput is 3 times faster. And moving forward, we think on the Ceph, and all the storage, especially for Ceph, we think we can remember my middle better configuration. I can use Optane drive as a journal or the MAC data or RockDB, whatever DB MAC data, and then I use 3D NAND like P3520, a large capacity drive as backend OSD. So this gives you both performance as well as high capacity and low cost. Also for the PM store, we think the Optane drive, the Optane technology can be well fit. So you can replace the backend, replace BlueStore block device, or as well as the RockDB WL, write ahead log file. Intel opened doing the open source, contribute open source with the library. Those 2-3 libraries can be used, so you can develop your application directly on the Intel Optane technologies. So that's for today, and I think the Ceph is beautiful. It's moving to the All Flash, and the OLTP, all the applications needs a high performance. That's why we focus on the All Flash development and the tuning on Ceph. With the Optane drive, the 3D crosspoint, and 3D NAND technology coming on board, we think those two getting together should we get much better performance as well as lower cost effective. Thank you.